Cement Evaluation Workflow. This video demonstrates a typical cement evaluation workflow based on sonic and ultrasonic logs. Click on Load and select the data file. As cement logs typically incorporate waveforms and arrays, the most common file format is DLIS. Data from multiple passes or from different tool modules may be contained in a single DLIS file. The Array Data tab displays all the maps and waveforms contained under a certain pass. The most relevant arrays for a cement evaluation are selected by default, and the user may load other arrays simply by ticking the box in the last column. The type of the selected arrays determines the associated processing to be performed. In this case, 2 impedance arrays will be loaded. The Mapping tab shows the channels contained in each pass. The most relevant mnemonics from the main cement tools in the market are automatically identified by Emeraude. Unidentified mnemonics may be defined by the user. Proceed with import. Cement Logs display is greatly facilitated using predefined templates. Click on Templates. The Well Integrity folder contains layouts for various cement tools. Select Use It. The tabs in red indicate that it is necessary to define the data container for different tracks. In this case, all the channels are contained under Up 1. After ticking this box, click on Apply Current Binding to All. Apart from cement logs data, this layout includes internal radius and thickness measurements recorded by the same tool. As this video focuses on cement evaluation, the unnecessary tracks are removed. The color scales of the array maps have a built-in association, typically used in field prints. It may be necessary to adjust the range of some of the arrays. For example, right-click on the VDL, select Min-Max, and set the scale between 0 and 1000. The cement evaluation options are contained in the Well Integrity tab. First, we will calculate the bond index and attenuation. This requires the free pipe amplitude and 100% bonded voltages. Click on Compute. 2 new tracks are automatically generated. Right-click on the CBL track and display the free pipe and 100% bonded levels. These can be edited interactively by moving the lines directly on this track. Right-click on the bond index track and select Fill Area. It is common practice to highlight intervals with bond index larger than 0.8. Use a green sharing. The overall isolation criteria are composed of 3 separate analyses. The first one is the casing to cement bond, which may be based on the acoustic impedance or CBL. It is up to the user to define which one is the most representative, as both are impacted differently by factors such as microannulus, wellbore fluid, etc. From Show, select Average Acoustic Impedance. Two transition levels define the zones for good, acceptable, and bad cement. Right-click on the impedance track and display these levels. These can be edited interactively or manually. The good impedance level is based on the expected value for the specific cement type after curing. In this case, we will enter 5.2 megarails. The acceptable value is arbitrary, below which the cement is likely to be bad or patchy. In this case, we will enter 4 megarails. Click on Compute. The cement-to-casing bond analysis is conveniently displayed as a traffic light system with different colors for good, acceptable, and bad cement. The casing colors result in spikes in the acoustic impedance, affecting the results of this analysis. We will deal with this later. The next step of the overall isolation criteria is the cement-to-formation analysis. When the sonic wave propagates into the formation, changes in lithology are reflected in the VDL as crooked lines after the early casing arrivals. Click on New User View. A blank track is created. From the browser, drag and drop the VDL and the gamma ray on it. This helps to identify intervals with formation arrivals. Click on the Formation Zones button and interactively define the intervals with formation arrivals based on the qualitative inspection of the VDL and gamma ray. The newly created zone is displayed in brown in a dedicated track. The final step of the overall isolation workflow is to identify intervals with channeling. This is done interactively using the acoustic impedance image that shows in blue the impedance values corresponding to liquid. Click on Channeling flag and identify the relevant areas. These are also displayed in the Well Integrity Zones track. The AIBK array also displays the acoustic impedance map with a different color scale. Right-click on it, select Properties, and assign a CCL measurement to it. Select Explore. Click on Show and select the CCL. Using the interactive option, identify the connections between casing joints. A newly created track displays the joints. This information will be used to exclude the affected data at the connections from the final results. Select Cylindrical 3D Display. The acoustic impedance map is displayed for each casing joint. Increase the radius gain to see more clearly the 3D image. It is useful to filter out the data with acoustic impedance in the liquid range to highlight the channels. Click on Filter and set the minimum to the colors representing solid behind casing. Toggle to other joints to see the results. From the Well Integrity tab, click on Results. This option combines the results of the casing to cement analysis, formation arrivals, and channeling flags. The table shows the results of the individual analyses and the final overall isolation results. Note that the connections are excluded, meaning that the spikes in the acoustic impedance will not affect the final results. A minimum interval length of 1 meter is used to highlight intervals with good or acceptable cement that fall below a minimum level. The overall isolation results are also presented in a dedicated track with a traffic light system, indicating the potential for annular isolation. The overall isolation results must be updated if there are changes in one of the individual analyses. For example, in this case, the acoustic impedance is affected not only by the connections, but also by the external casing centralizers. Go to the Edit and QA/QC tab, and using the Pick Nearest option, activate the Average Impedance Curve. Click on Filter and select a median filter of 1.3 meters. The filtered curve is now clear from the connections and centralizer spikes. Go back to the casing to cement analysis and recalculate the flags without modifying the good and acceptable levels. The overall isolation results must be updated. Click on Results and calculate. The latest results of the individual analyses are used. The Joints table shows the main cement evaluation results for each identified casing joint. This concludes this video on cement evaluation workflow.